Okay, so if what we have is a postulate that's angle-angle similarity, and it says that if two angles of one triangle are congruent to the corresponding angles of another, has an O in it, triangle, then the triangles are similar. So if I have two triangles, and this angle is the same as that angle, and they're in the same position, and this angle is the same as this angle, and they're in the same position, I mean the triangles could be rotated, but they're in the same relative position, then the triangles are similar. And the way this will work is because a triangle is 180 degrees no matter what size it is. So these two, and if you subtract them, you'll get whatever this angle is. Those will also match. So you have three angles that match, so you have similar triangles. So you don't have to know all three angles, you only have to know two, because once you know two, the third one automatically matches. Make sense? Okay. So there are lots of ways to prove all this. We are not going to be doing all of this. All we need to know is that. So two angles are congruent, then the triangles are similar. Okay. So here we have two triangles that are nested, kind of like those nesting dolls. We have nested triangles. If we pull them apart, they're sharing this angle. And because they're sharing that angle, it makes it the same. So that means these two triangles are similar because we have two congruent angles. Sometimes you don't have to tear it apart if you can see this together and say, okay, one angle, and then they're sharing that one. You can say these are angle-angle similarity. But if you have to, you take the picture apart and label it and look at the two triangles separately. Alrighty. Here I have more kind of nested built triangles, and I need to find, they did it again. Alright, what I have three triangles. I have the big triangle, I have the medium-sized triangle, and I have the itty-bitty triangle. Okay. Well, I'm going to break them up into I'm going to break them up into all three, just for labeling purposes. I have a big triangle, a medium triangle, and a little triangle. Okay. For my little triangle, the short leg is Y, and the longest leg is X, and this one is 16. Did you guys see that? And that's that angle right there. In my really big triangle, the short leg is X, this leg is 30, and this leg is 32. And then in my medium triangle, I don't know for a fact that this angle matches those. It's not marked. But I'm going to go ahead and say the short leg is 16, the longest leg is 30, and then this leg right here is 32 minus Y. And then I'm going to pick two triangles to use to find X and Y. Because this has that 32 minus Y in it, and I'm not 100% sure this is the right angle, I'm going to go ahead and get rid of that one and decide not to use that triangle. Because the 32 minus Y makes the math a little bit harder, and because I'm not 100% certain. It probably is congruent, but I'm not 100% because it's not marked. So I'm going to use the biggest triangle and the smallest triangle. And X and Y are on the same side, which means they're going to be proportionate to each other. Which means in order to find Y, I'd have to know X, or in order to find X, I'd have to know Y. Well, because there's an X here with this 32, I'm going to find X first. And so 16 and 30 go together. They're on the same position. and 32 and x will go together because they're in the same position. So I can say x over 32 is equal to 16 over 30. And I see why they put the numbers the way they did, even though they made no sense. Okay. So 30x is equal to 16 times 32. We cross multiplied. And I have not actually memorized my 16s, believe it or not. So 16 times 32 is 512. So 30x, wrong color. 30x equals 512, and then I'm going to divide both sides by 30. And I will get x is equal to 17.06, repeating. Okay, so far all right? Well, now I have x, that is 17.06, repeating, which is approximately 17.07. I need to find y, and x and y are proportionate, and this x and that x are the same, so this one is also 17.07. I'm still going to use 16 and 30. So now I will have y over 17.07 is equal to 16 over 30, which will give me 30y is equal to 16 times 17.07, which is 273.12. Divide both sides by 30. And I get 9.1. Or have, two angles in common. So here I have these two angles and these two angles. This angle with that and that angle with that. So I know they're similar. So I know the sides are going to be in proportion. If I look, this triangle has been, turned clockwise, like it rotated around. But we still have these angles together, so 4 and x would be in the same position. And then this angle, 5 and y are going to be in the same position, and 3 and 6 are going to be in the same position. So to solve this, I'm going to need to make the proportion. And I'm going to do this on the next slide because there's obviously not enough room here. But I have x and 4 together, and 3 and 6. Cross multiply, I get 6x equals 12. Divide, x equals 2. So far okay? So x is 2. And then the y and the 5 go together. Still 3 and 6, so I get 6y equals 15. If I divide by 6, y is either 5/2, or you can say 2.5. Up to you. Okay, when I have here a nested triangle again, I'm going to draw those as best that I can. Get my special triangle drawing tool. Okay, so I have my two triangles. I've taken them apart. See, this was A, this is C. The long side of the big triangles, or this side of the big triangle is x, and on the small triangle it's 6. So I have an x and a 6. This side of the big triangle is 5 plus 10. And on the small triangle, it's just 10. Did you guys see that? Okay, then I have the small triangle is y, and the big triangle is 4 plus y. So far, okay? So 10 and 15 go together. X and 6 go together. And 4 plus y and y go together. So I'm going to solve x first because it's simpler. 6 over x is equal to 10 over 15. Cross multiplying, I get 10x is equal to 90. Let me just double check myself on that. Yes, 90. So x equals 9. But now with my y, it's going to be a little different because I have a y and I have a 4 plus y. So I'm still going to use the ratio. I'm just going to switch it to y plus 4. And then 10 over 15. But now when I cross multiply, I'm going to have y times 15, which will give me that 15y. And I have 10 times y plus 4. So I have to distribute 10 times y and 10 times 4. So what I get is 15y is equal to 10y plus 40. Subtract the 10y from both sides. And 5y equals 40, so y is 8. Not too bad, I hope. So for this one, since the 12 is the whole long side, the x and the 12 go together. And then 3 goes with 3 plus 6. Because it needs to be the whole triangle. Let me break it into two triangles. I have a big triangle and a little triangle. This is x, this is 12. This is 3, but this is 3 plus 6. So that makes it 9. And then this is y, and that's 9. Does that help, breaking it in half? Okay, so then once it's broken, you can see that the x goes with the 12, and the 9 goes with the 3, and then this 9 goes with the y.
So you do the 12 over x.
Or x over 12, but if you want to, you can do 12 over x is equal to 9 over 3. And then when you cross multiply, you get 9x is 36. And then you divide by 9 to get that x is 4. Better? And then for the y, same thing. When you cross multiply, get 9y is 27. So y is 3. So I had 3 and 6 here and here. So the small triangle is 6, and then the big triangle is 3 plus 6, so that's 9. And then I have x and 9, so the big triangle is x, and the little triangle is 9. And here I have 4.5 and y. So that little triangle is y, but this big triangle side is y plus 4.5. Because it has to be the whole side. So far okay? Okay, so then matching up, 9 and 6 go together. X and this 9 go together, and then y and y plus 4.5 go together. So x over 9 is equal to 9 over 6. I think I wrote down the wrong answer. Yeah, I did. I did what I told you guys not to do. I flipped one of my triangles and put little over big and big over little for the other one. So it is not 6 because 81 divided by 6 is not 6. 81 divided by 6 is 13 and a half. So that was my mistake. So let me fix that real quick. Okay, and then for, excuse me, for the y's, I have y plus 4.5 over y is equal to 9 over 6. When I cross multiply this, I'll get 9y is equal to 6 times y plus 4.5. And 4.5 times 6 is 27. So if I subtract 6y from both sides, I get 3y equals 27. And that makes y equal to 9. The first one we have is the side angle side similarity, which is similar to side angle side congruence, but this is just similarity. So if an angle of one triangle is congruent to an angle of another triangle, and then the lengths of the sides, including these angles, is proportional, then the triangles are similar. So if I have two triangles, and this angle is the same, and let's say this is x, and this would be 2x, and this would be y, and this would be 2y. When I make a proportion, they're equal. So as long as we get proportional sides with a congruent angle in between them, then the triangles are similar. And then side, side, side similarity is when you get all three sides, pairs of sides in proportion. So if I have two triangles, and I'm just going to go ahead and call these x, y, z, and I'll just call this a, b, c. X over a would be equal to y over b, which would be equal to z over c. So all of the sides would be in proportion to each other. Say whether or not the two triangles are similar. So when we look at, we have this embedded nested triangle situation again. So you break them apart into a larger and a smaller. This side is the 4 because it's the 2 plus 2. And then we need to see, right now I have a side, an angle, and a side. So it looks like they should be similar by side, angle, side, but I need to make sure that the sides are in proportion. So again, like I said, I like to put the small one on top. I need to make sure that this is a true statement. So I cross multiply, and 1.5 times 5 is 7.5. Oh wait, I wrote 2 over 5. It's 2 over 4. I don't know where I got the 5. Okay, 1.5 times 4 is 6. And 2 over 3, or 2 times 3 is 6. They are equal. So yes, the triangles are similar. Helps if you write down the correct numbers. Okay, for the next one we have the 3 sides. So we're going to try for side, side, side similarity. So I need all 3 sets to be proportionate to each other. So I will have 4 over 6 as one, 6 over 10 as another, and 8 over 12 as the final one. So if I cross multiply here and then cross multiply here, I should get the cross multiply here, I should get the same number. Cross multiply here, I should get the same number for both of those. And then I need to cross multiply the first and the last to make sure all 3 are in proportion, or I need to get all of these into an equivalent form. Either A fraction with the same denominator or a decimal. So which would you guys rather do? 3 cross multiplications? You'd rather do the cross multiplications? Okay. So we'll do the first one, which will be the 4 over 6 and 6 over 10. And cross multiply that, and I get 36 and 40. These are not equal. Already I know that the triangles aren't similar. So I'm going to go ahead and write not similar. But if these were equal, we'd keep going and do 610 and 812, and I would get 72 and 80, which is also not equal. And then if I keep going, 4, 6, and 8, 12 gives me 48 and 48. These two are equal. But they'd have to all three be equal for the triangles to be similar. So as soon as you hit one that's not equal, you can stop. But if this one was equal, then you need to try the other two and make sure all three are equal. Because if I had done this first and only this, I would have thought that they were similar. So a not equal, you can stop. But if you keep getting equals, you have to keep going until you've done all three sets. Make sense? Okay. And we're going to use the same thing we were doing before. I'm going to go ahead and break this into two triangles. I have the smaller triangle and, whoops, that's not even, the larger triangle. The small one is 30, 24, and x. The large one is 30 plus y, 24, and 24 plus 8, which is 32. And 30 plus y go together, 24 and 32 go together here, and x and 24 go together there. So 24 over 32 is equal to x over 24. Anybody know 24 squared? Okay, divide both sides by 32. And x is 18. And then for my y, 30 over 30 plus y is equal to 24 over 32. Don't make a very common algebra mistake and think that these 30s will cancel. If it was 30 times y, they could cancel, but because that plus is in there, if there's a plus or a minus, they can't cancel. Okay, so make sure you don't do that. I'll have 24 times 30 plus y is equal to 30 times 32, which is 960. And then 24 times 30 is 720. I'm going to take 720 away from both sides. And that will give me 24y equals 240, which makes y 10. Why don't you guys try all four of these just to make sure that you've got it down, and then all of the triangles are similar, so you don't have to test the similarity. Just be sure you can break them up into their relative triangles and solve for the missing letters, and then we will go over them all together.